Uh, Hi and good day everyone. I am Jason Villabito, a Bachelor of Science in Civil Engineering student, and I would report for today is about alternating current, or also known as AC. Have you ever wondered what kind of power are we using in our daily lives, especially at home? The things we put on our sockets. It may be a computer, charger, device, or anything. Well, it's alternating current. And for many centuries, these inventors help us in a great way, building this civilization up to now. And these two are the greatest. And I think you also know of these two. One is Thomas Edison for DC and Nikola Tesla for AC. Today I'll be discussing basic concepts of alternating current limited to these topics. One is alternating current, second is voltage, second is current and phase. The last one would be peak, RMS, and average values. Alternating current are also known as AC. Alternating current, a flow of electron charge that periodically reverses. It starts from zero, grows to a maximum, decreases to a zero, reverses, reaches to a maximum again, and in opposite direction. Returns again to the original value and repeats these cycles indefinitely. Well, unlike DC, which the current flows on one direction, while alternating current oscillates from one direction to another. In our homes, we've been using powers like it's always been there, but there's a great concept about these currents that we've been using, especially this AC in our homes. We've been generating power through water or hydro, next, and winds. It may be solar or nuclear, but on AC, since this is an efficient way of transferring high voltages, and unlike DC, which does which is not efficient on transferring voltages or powers currents on a high mile or on a great distance. That's why we've been using AC, because of this concept. First is that the generated power would be uh, transferred to generator. Next is to high transmissions line, and next to is another transmission lines that would be uh, calibrated to a lower voltage that we can easily and safely use in our houses. From distribution line to service line. Well, voltage. Voltage is the pressure from an electric circuit's power source that pushes the charge of electrons through a conducting loop, enabling them to do work such as illuminating a light. Alternating currents are accompanied or caused by alternating voltages. An AC voltage, or V, can be described mathematically as a function of time by the following equation. Voltage in time is equal to the voltage peak voltage times the sine omega times t. Voltage is the pressure from an electrical circuit's power source that pushes charged electrons current through the conducting loop, enabling them to do work such as illuminating light. As I said earlier, alternating currents are accompanied caused by voltages, where in the equation V peak, or the voltage peak, is the peak voltage, which has a unit of volt. Omega is the angular frequency. It is a unit of radians per second. The angular frequency is related to physical frequency, or in this symbol, which is hertz, which represents the number of cycles per second, with equation omega is equals to 2 pi times frequency. T is the time. Here is an example of a DC circuit. As I said, the flow of electrons is going from positive to the resistor, going to the negative. While in alternating currents, if you put at 120 volts, it goes here back to the resistor, and it oscillates. Well, the frequency would be 120 hertz. Well, in an average household, we've been using 120 volts of power. The frequency would be 60 hertz. Phase: if a mass on a rod is rotated at a constant speed and the resulting circular path illuminated from the edge, its shadow will trace out a simple harmonic motion. If the shadow vertical position is traced as a function of time, it will trace out a new sine wave. A full period of the sine wave will correspond to a complete circle, or 360 degrees. The idea of phase follows this parallel with any fraction of a period related to the corresponding fraction of a circle in degrees. To experiment, this is experiment on how to see the effect of a sine graph or a sinusoidal graph. For example, there is a rod and it is move on a circular constant speed. The reflection of shadow would be from 0 to this line, going upward, back to its position, going downward position. This from here, I would say this is 0, and from here it would be a full cycle of a sine graph. Phase is a fraction of cycle expressed in degrees. When capacitors or inductors are involved in an AC circuit, the current and voltage do not peak at the same time. The fraction of a period difference between peaks, expressed in degrees, is said to be the phase difference. The phase difference is greater than or equal 90 degrees. It is customary to use the angle which the voltage leads the current. This leads to a positive phase for inductive circuits, since current lags the voltage is in an inductive circuit. The phase is negative for the capacity circuit, since the current leads the voltage. The useful Naomic Eli and the Iceman helps to remember the sign of the phase. The phase relation is often depicted graphically in a phasor diagram. In the figure, it says that unlike DC, it's not the same as AC. The circuit graphs. Well, in DC, it would be just like this. In the direct current, it has a straight line passing through time. But in alternating current, as I said earlier, it oscillates. It is sometimes helpful to treat the phases as if it is a defined vector in a plane. The usual reference for zero phase here is the taken to be positive x-axis and is associated with the resistor, since the voltage and the current associated with the resistor are in phase. The length of the phasor is proportional to the magnitude, the quantity represented, and its angle represents its phase relative to that current through resistors. Well, alternating currents have big difference on the DC. Peak, RMS, and average values. RMS, in alternating currents, the magnitude of the current is always changing for an AC. Therefore, the current can be described by not just one but several numbers. RMS and peak are two numbers that can be used to express alternating current. The main difference between RMS and peak is that the peak refers to the maximum value that the current can reach in an alternating current, whereas RMS is the peak current divided by the square root of 2. The term RMS stands for root mean squared, also called the effective or heating value of alternating current, is equivalent to a DC voltage that would provide the same amount of heat generation in a resistor as the AC voltage would apply to the same resistor. RMS is not an average voltage, and its mathematical relationship to peak voltage varies depending on the type of the waveform. Well, if you say that it has a higher peak, voltage peak, well, it would be higher RMS. If it is a lower voltage, it would be a lower RMS. Basically, that's the concept. The RMS value is the square root of the mean average, the value of the squared function of the instantaneous values. RMS voltage is useful in calculating the average power in a circuit. Since AC voltage rises and falls with time, it takes more AC voltage to produce a given RMS voltage than it would for DC. Just like I said earlier, this is the voltage peak and this is the PRMS. For example, we have a 240 volts here. That would be equivalent to a 240 DC voltage on a straight line. And then this is an half cycle and this is a one full cycle from 0 to 360. It does also have a positive peak and negative peak since it oscillates from upward to downward direction. It's not stable, it's not on a straight line just like on DC voltage. Important equations. Well, to calculate the voltage RMS, the voltage peak times 7.07, the voltage RMS is equals to 1.1 times voltage average. 1.141 times VRMS is equals to VP, and the average is 6.37 times VP. Well, ito lang yung ating i-consider for finding voltage RMS. If you have a volt peak of 240, let's say, to find the voltage RMS, we would multiply it by 1.414, or this is a shortcut of square root of 2. To find naman the average, we would multiply 0.637 times the voltage peak. Peak voltage, the maximum instantaneous value of function as measured from 0 to volt level. The peak amplitude and the peak value are the same since the average value of the function is 0 volts. Peak to peak voltage is the full voltage between positive and negative. Parang kanina, from positive peak to negative peak of the waveform. That is the sum of the magnitude of the positive and negative peaks. Well, RMS voltage, the root mean squared effective value of a waveform. Yan, ito yan. Average voltage, the level of waveform defined by the condition is that the area enclosed by the curve above the level is exactly equal to the area enclosed by the curve below this level. So, balikan natin yung ito yung peak, ito yung VRMS. Pag peak to peak, it would be from the positive to the negative. Well, to summarize the report, AC is more efficient in traveling power current than DC. As said earlier, mas efficient talaga si AC kumpara kay DC since pag DC kasi ang kinamit natin, hindi siya cost effective sa power line since mag-heat up talaga siya at hindi niya kaya yung mahabang distance. AC have a sine or a sinusoid phase voltages diagram or graphs. Yung kaninang nasabi ko po ay yung graphs ng AC, which is sinusoid. Voltage is the pressure from an electrical circuit's power source that pushes charged electrons to a conducting loop. Phase is a full cycle of voltage current. RMS, peak, and average are different and have the following equations. This is the reference I use on the report. Well, I hope that you have understand the basic concepts on AC or alternating current. And thank you. Have a good day.